Hey, good morning, everyone. So today we're gonna kind of talk a little bit more about our vertex and factored form, but mostly how we use those to convert to our standard form. So just to remind you, our vertex form is that a times x minus h squared plus k, where hk is our vertex. I'm going to put standard in the middle here. Remember, that's y equals ax squared plus bx plus c. And here you'll notice that a's are consistent. And so you're ultimately going to see that the a value in vertex is going to be exactly the same as the a value in standard. One thing we haven't covered yet is that c value there ends up being the y-intercept. Not super essential for today's lesson, but keep that in mind because we'll take advantage of that fact later. And then finally, we had our factored form, where y equals a times x minus one of the x-intercepts times x minus the other x-intercept. All right, those are our three forms. So our goal is to go from vertex to standard and also to go from factored to standard. So to do that, we're actually going to take advantage of some of the facts we've been using, I guess, since the early days of this class. So I'm going to take a quick look here. So as we're doing this, ultimately, we're going to take a look at the graphs in vertex form for this first example. So we have this y equals 2 times x plus 3 to the second power minus 7. So you'll see that we have this parabola here in red. I'm betting that once we convert, we'll get to this format, but we'll talk about that in a second. And then the other example we're going to look at is this example in factored form. And that's the one in purple there. And we're going to see how we can convert that to standard form, which once again, I'm arguing is going to look like this equation. All right. So here's our example here, and here's our example here. Let's start. Remember, to the second power just means we're doing something times itself. So when I'm doing this, I'm going to expand it. And what I mean is instead of x plus 3 to the second, I'm going to write it as x plus 3 times x plus 3. I didn't change anything other than the fact, instead of keeping it nice and condensed to the square, I said the square really means it's x plus 3 times x plus 3. All right. Now, I'm going to use one of the skill sets we've used in the past. So remember, when all this stuff is written next to each other, it really just means multiply. So to keep my life as easy as possible, sorry, I had to reach for a different pen. I'm going to focus entirely on this stuff to start. So notice how it's 2 times these two things multiplied together. So what I'm going to do to start is deal with these two. And remember, if I'm going to multiply those things, I want to think about my box. So in this case, I have an x plus 3 times an x plus 3. So x times x is going to be x squared. Positive 3 times x is going to be positive 3x. X times positive 3 is going to also be positive 3x. And positive 3 times positive 3 is going to be positive 9. All right, so now I have all of these things in this box. So instead of that x plus 3 times x plus 3, I now know that all of that stuff is there instead. I'll zoom in here. So all I did was x plus 3 times x plus 3. And so all of that stuff replaces it. I did my multiplication, and those were all the inside terms. And I'm just going to simplify that a little bit because I have a 3x and a 3x. So when I add those, I'm really going to have x squared plus 6x plus 9. So nothing too terrible yet. I'm just using skills we've had all along. And finally, I now have this 2 times all of this. So I'm going to use my distributive property, and I'm going to have to multiply to all 3 terms. So that's going to be y equals 2x to the second plus 12x plus 18. And I still have that minus 7 hanging out on the end. And if you notice, here's that plus 18 and minus 7. I can definitely simplify that. So that would be right here, my final answer in standard form. Because if you notice, I have an ax squared plus bx plus c. Ax squared plus bx plus c, where my a is 2, b is 12, and c is 11. And as I said before, notice how up here in vertex form, my a value is 2. In standard form, my a value is also 2. All right, so let's take a quick look at the graph here. All right, so as promised, these two match up perfectly. So all I've shown is that my vertex form and my standard form are equivalent because they make the same exact graph. All right. Now, let's take a look at our factored form. So we're actually going to use almost all the same things from over here, just this one's a little bit simpler because there's no plus or minus anything on the end of it. So in other words, I'm going to once again say, remember all these things are being multiplied, and I'm going to start by focusing just on this piece. So I know I'm multiplying things to binomials, I should say, not things. So I'm going to make my box again. This time I have an x and a minus 1 and an x and a minus 2. You'll see x times x is x squared. Negative 1 times x is going to be negative 1x. X times negative 2 is going to be negative 2x. And negative 1 times negative 2 is going to be positive 2. All right, and so now, instead of negative 4 times those two separate binomials, it's really going to be negative 4 times that x squared minus 1x minus 2x plus 2. All right. And now, once again, if I look, I can make my life easier by simplifying the terms inside real quick. So I still have x squared, but I have that minus 1x minus 2x, which will become minus 3x. And then I have my plus 2. All right, and so now this is all nice and simplified. So now I can do my negative 4 times, meaning I got to distribute to everything. And now I have y equals negative 4x to the second plus 12x, and then minus 8. All right, and once again, this is in the form of ax squared plus bx plus c, where a is negative 4, b is 12, and c is negative 8. And once again, notice how here my a value was negative 4, and in my final standard form, my a value is negative 4. All right, so now let's take a look at the graph. Turn that one off. All right, there was the original. And here is what we got after we converted to standard form. And you'll notice, once again, that there's the same exact parabola. All right, So the last thing I want to illustrate right here is notice how in this format it said plus 11 on the end for C. And what you'll notice is that blue parabola, sure enough, crosses the y-axis at 11. Notice for this black parabola that -8 is on the end, and sure enough, you'll see that it crosses the y-axis at -8. So once again, not critical for right now because we're just doing conversions, but something to take note of in the future, that that number on the end is going to represent our y-intercept when in standard form. All right. If we take a quick look at today's assignment, you'll see that there's just a bunch of opening simply convert from vertex or standard to, or sorry, vertex or factored to standard. And remember problem 3, think about what number's technically in front of parentheses. And then you're going to have 2 more problems on top of that, where I simply want you to come up with 3 versions of a quadratic equation that go through the points given. So you should be able to write something in factored form, vertex form, and standard form. And for these, type them in, and then you've got a graph that you can use to check on the next slide. All right, so let me know if you have any questions. Otherwise, good luck, and I look forward to checking out your work.